Hi everyone, welcome back once again. We are still continuing with our mathematics paper 2 revision, and today we're going to look at question 8 from your November 2021 past paper, focusing on two-dimension trigonometry and application. Okay. All right, question 8, we are given in the diagram below. T is a hook on the ceiling of an art gallery, right? We have points Q, S, and R that are on the same plane from where the three people will be observing the hook T, okay? So we are given that the angle of elevation from Q to T is X, and it's indicated in our diagram. Q angle SR is equals to 90 plus X. Q angle RS is equals to X, also shown in the diagram. QR is equals to 5 units and TS is equals to SQ. Okay, it's also denoted on the diagram. All right, 8.1, they want us to prove that QS will be equals to 5 tan X. Okay, so meaning that we have to go and calculate the length of what? Of QS. Okay, QS. How can we get QS? Which triangle can we use? I think the most detailed triangle is this shaded one, right? So because we are looking for QS, so you ask yourself, is there an angle facing QS? Yes, it's X, right? So X is the angle that is facing QS, and you also have another side which is QR, which is 5, and there's another angle facing it which is 90 degrees plus X. Okay, so meaning that we can use the sine rule because we have two angles and we have one side, we are looking for the other side. Two angles, two sides, we can use the sine rule. Okay, so 8.1, we are going to use the sine rule, which says because we are looking for QS, we'll start with this length, QS divided by the sine of the angle facing it. So the angle facing QS was what? Is X. So it will be the sine of X is equals to then another length that we have is what? Is QR divided by the sine of an angle facing it. So the angle facing it is what? Is 90 degrees plus X. All right, so we can simplify this, and we know this is basically the what? The sine rule, right? So we can simplify this. We are looking for QS over sine X is equals to, what is our QR? We are given QR is 5 units, 5 over what is sine 90 plus X. So 90 degrees plus X is found on the second quadrant where we have sine, meaning the answer must be positive because it's in its position. But 90 degrees will change sine into what? Into cos, because it's a cofunction. It will be cos x. Okay, so to solve for qx, we can just simply cross multiply. Then qs will be equals to 5 multiplied by what? By sine x. All these are being divided by what? By cos x. All right, take a look at this. Sine x over cos x. Okay, sine x over cos x, it's an identity that is equals to what? Tan x. Then we have proven that indeed qs is equals to 5 times tan x. All right. 8.2, they want us to prove that the length of qt is going to be 10 sine x. 10 sine x, this length. Qt, it's this one here. Okay, they want you to prove that it's going to be 10 sine x. Okay, so let's look at our diagram. QT is there an angle facing it? We don't have an angle there, right? But we can basically calculate it because we are given that this side is equals to this side. So our first step can be really to tell them that actually our what is this angle here? T angle QS, right? T angle QS is basically equals to Q angle TS. Okay, so we are saying this angle here is equals to that angle because that's an isosceles triangle. Base angle are equal. Both of them are equals to x by what? Because angles opposite equal what? Equal sides. Okay, so the angles that are opposite are equal because of the equal sides, right? Yes, so then we can actually determine this angle there, right? So that we can go and use our sine rule. Someone can choose to use cos rule because we have all the sides and all the angles. Okay, so you can choose which one you're gonna use. Let's go and calculate that angle. We know that our angle x plus x, right, in the diagram, plus this one that we are looking for, which is q angle st, right, they all sum up to what? 280 degrees because of some angles of a triangle. Okay, some angles of a triangle. Then the q angle st will be equals to 180 degrees minus what? Minus 2x. So meaning that there, let me just put it, this 5 times x. So this will be 180 degrees minus 2x. All right. So that's the angle there. Now we can go and use our sine rule, right? Because we have QT now. We are looking for QT and we have an angle facing it. We have calculated it to 180 minus 2x. And we also have those other side, right? We can either use QS and the angle facing it is x, right? Or rather you can choose to use TS, the same angle facing it, it's x. So you can use the sine rule now. All right. So the sine rule will be QT divided by what? The angle facing it, which is the sine of 180 degrees minus 2x is equals to, the other one we can just choose QS divided by the sine of the angle facing it, which is x there. So it will be divided by the sine of x, right? Then this will be QT divided by what is sine 180 minus 2x. We know that 180 minus an angle is found on the second quadrant where sine is positive. So when we reduce it to be sine 2x, all right, is equals to, what is our QS? We've just proven that QS is equals to 5 tan x. So we can replace that by 5 tan x, all divided by what? By sine x. So to solve for QT, we're going to cross multiply. QT is going to be equals to sine 2x multiplied by 5 tan x, all divided by what? By sine x. All right. So we can simplify that expression. So what is sine 2x? So we have QT is equals to, what is sine 2x is a double angle of sine. It's going to be 2 sine x cos x, right? What is multiplied by 5, right? So it's being multiplied by 5. What is tan x? Tan x can be simplified into what? Into sine x over what? Over cos x. All right. All of these are being divided by what? By sine x. Okay. So now we'll see cos x and cos x will cancel out each other, and sine x will cancel out each other. Then QT will be left with 2 times 5 multiplied by what? By sine x. All right. So this will be 10 sine x. Then we have proven that indeed QT is equals to 10 sine x. Just simply using the sine rule. Someone might have chosen to use the cos rule, right? Because you are looking for QT is the only length you don't have in this triangle. So this QT, you can say QT squared is equals to TS squared plus QS squared minus 2 TS QS cos of the angle facing QT, which is cos of 180 minus 2x. But that will probably take you a lot of time to simplify and stuff. So basically you can just use the sine rule, which is quite easier. All right. Right, let's conclude with the last question, 8.3. It says, calculate the area of triangle TQR, right? Triangle TQR is the bigger triangle, the TQR. So is this big triangle, right? They want us to get the area of that. If TQR, I mean T angle QR is 70 degrees, so we are given the angle there. So this angle is what? Is 70 degrees, and X is equals to 25 degrees, right? We are also given X there, which is what? 25 degrees. They want us to get the area of the bigger triangle. Okay, so we can use the area rule, right? So we can say area of triangle TQR is equals to 1 over 2. Which length do we have? We have this length, which is QR. We'll say times QR multiply by the other one which we have is this one, qt, because we are given x is 25, so we can substitute and get qt. So we say multiply by qt, the sine of the included angle between the two sides that we have chosen. So it will be the sine of q, right? Sine q. We can simplify this. It will be 1 over 2. What is our qr is 5. Multiply by qt, it will be what? 10 sine 25, because we are given x is 25. Multiply by the sine of q angle, we are given that angle as what? As 70 degrees. All right, so you can just simply punch your calculator and get the answer. So the answer will be 9.93 units squared. All right, because it's area, so it's in square units. Otherwise, great off. That's all for today. Thank you very much for watching. You can just check out some of our lessons that are appearing on your screen right now, and you can get more content knowledge from that. Otherwise, that's all for me. Thank you very much, and goodbye.